All right, guys. So today, what you're gonna do is you're gonna take the notes. The note page is attached with this assignment. You're gonna watch this, answer the question, then you're gonna go do an ed puzzle with Bill Nye, watching on erosion. There's a couple of questions you gotta answer for that, and that is it for today. Okay. And so erosion does have to deal with weathering. It is a form of weathering. Rocks are eroded by sun, weather, and temperature fluctuations. That means hot and cold. Remember, when rocks have the cracks in them and freeze, expand, and break apart, that frost action, that's a part of erosion because it's eroding the rock away, which the rock will eventually break off. When pieces are small enough, they can be transported by wind, water, and glaciers. We are going to look at wind and water today. Glaciers is going to be on Friday. And then again, next week, we have a benchmark. It's 20 questions. And then we're going to have review for the whole unit. And then on Thursday, you're going to have your test. All right, so erosion, wind. So we're going to look at wind. I think I blocked by that. Wind is only powerful enough to pick up sand, silt, and clay. These are small particles. You can see this in your reference table on page 6. It's that weird stream velocity, which we will get to on Thursday. So wind is only powerful enough to pick up sand, silt, and clay. Sand at high velocities in a sandstorm, like this, can do damage to your skin. It is possible that it can be ripped off. Now, what I mean is, on Mars, the sandstorms can reach like over 200 miles an hour. That will literally it could, if you're out there by yourself, it could rip your clothes off, it could rip skin off because it is that abrasive and going that fast. For instance, in an auto body shop, they use a sand blaster. It's going, like, the sand's going pretty darn fast, and it is using, the sand blaster is used to remove paint off the body of a car. So you can see this guy is sandblasting right there. Like, insane, right? Okay, some more on wind. So sand erodes rocks by leaving these little holes or pits in them. When the sand blown by wind is deposited, so you have the sand hitting and leaving pits and then still getting picked up. So you're looking at this. Look at all that sand. It's getting pushed. And when it's pushed and the wind starts to slow down, it is sorted by grain size. So the bigger they are, the faster they fall out, to the smaller. The smaller stays with it the longest. Oh, pardon me. And when this happens, a dune is formed, a sand dune. So sand dune deposits on the side called a windward side. Wind, that's where the wind is coming from. It's blowing. So the wind direction right here is moving this way. And this side is considered the windward side, the side where the wind is hitting it. And then on the other side, this side right here, this is the leeward side. There's no way that I can really match that with something like windward. It's the side the wind's going on. Leeward, it's just the opposite side. So the windward side of the dune is, and look at this type of slope. This is a gentle slope. And the leeward right here, that leeward side, that is a steep slope. Sorry. And you can see right like this, that steep slope. All right, so now we're going to look at water. Water is powerful enough to pick up pebbles, sand, silt, and clay. And you can see this. Sometimes if it's going fast enough, it can pick up boulders, cobbles, pebbles, sand, silt, and clay. So it depends on how fast the body of water is going, that the stream. So like Niagara Falls, if you've ever been there, it's got some pretty darn big boulders at the bottom, because when it gets going, when it gets flowing, it flows pretty darn fast, and it can carry that stuff along with it. Think of like in the spring, when you have all that, the snow melt, that helps increase the stream velocity, which helps bring the heavier, bigger boulders, cobbles, with it. So pebble, sand, silt, and clay, which you can see right here. When water is moving quickly, all the particles are in this suspension. So like if I was to shake them all up, they would be all in a suspension. And you couldn't tell the difference between the two. But as soon as you stop shaking, if you've ever had like one of those pretty little glitter things and you're shaking it up, everything's mixed together. But as soon as you stop, it starts settling down. The heavier stuff falls out first. So when the water slows, the pebbles, or the largest particles, fall out first. Then you'd get sand, silt, and finally clay. So you can see that right here. Like the boulders would drop out first, then the cobbles, the pebbles, sand, silt, and clay. And that would be like as the stream hits into the ocean or into a big lake. And this is called horizontal sorting, because look, it'd be going horizontally, like along the horizon, because it's spilling out. Okay, so this is one type of sorting. Now we're going to look at the second type. That's the vertical. This one is where the materials drop straight down, with the largest, most dense particles on the bottom and the smallest, least dense on the top. So remember how I was talking about, like, you take that bottle with that glitter stuff and you're shaking it and you stop and everything just drops out right there. That's what's going on here. Like in the lake, say there was a rough storm and it started mixing everything up, and then the storm stopped, and then it kind of just like stopped shaking and everything just starts to kind of settle. When it does that, you get the gravel, pebbles, sand, clay, and then the water. Silt would be in between the sand and the clay. So that's it for today. Your notes, I know, pretty quick. Don't forget to do the Bill Nye. And if you have any questions, please email me. Use class tag, hop on Zoom once a week. That's a requirement. All right, guys, have a great day.